Good morning, happy Monday, or I guess fourth block, good afternoon, happy Monday. So today we're going to start chapter 9, section 1. This will be in most likely our last chapter that we're going to cover. So congratulations, we made it to our chapter 9. I was hoping to get to chapter 10, but especially if we end up going back into the remote cohort in-person split setup. We'll be spending the last couple of weeks, it looks like, in our finals period. So we'll have to cut short what we are learning. If we stay remote, then I'm guessing it will be only 1 week of final stuff, which means we'll have an additional week, but I'll probably give that to you guys just to make sure that your final is complete and that all of your work is caught up. Now, I haven't sent out anything that solidifies exactly what we're doing, but I am just going to verbally tell you now, and I'm going to send out a sheet that kind of further explains it later on. But basically what we're going to be doing for our final is it's going to be a compilation of the performance-based assessments that you've completed for the second half of the course. So pretty much starting at chapter 6 with your performance-based activity where you did 100 trials and a modification of 100 more. Starting there all the way until the end of this chapter, I am going to give you a list of things that I want put into a presentation, and you are going to take the work that you've already completed. So for instance, I'm going to ask you for a list of your 2 sets of data for the original and for the modified, and have that be, or at least the statistics, so the mean and standard deviations, have that be on a slide, explain what you did, and then finding your sample size, finding your confidence interval, finding your hypothesis test, everything that we're going to be doing. You're just going to be extracting the information that you've already done, and you're going to be compiling it into a slideshow, Prezi, a website, whatever format you'd like. And then you're going to send it to me, and I'm going to compile it into one big presentation, and that will be your final. I'm not going to be asking you to present anything during the final periods. I will probably just have you guys just kind of take a look at what some of your classmates have done, and I might have some sort of thing like reply to one person making a comment about their work. I'll probably actually, I'm brainstorming right now as I'm talking. I'm probably going to assign you a person so that no one gets left out, and then have you attach me with your comment to make sure that it is done. So anyway, so just that is the rough draft of the final. There will not be a test. There will not be anything new. It's just going to be a compilation of everything you've done, which will be worth 15% of your grade. So in theory, if you've been staying caught up to this point, you're almost ensuring yourself a 100% on your final. So I thought that was a fair idea. I kind of wanted to bring all this together. But like I said, I'll be issuing out something later this week that kind of gives a more formal explanation of this. All right, so on to chapter 9, section 1. This is going to be an informational lesson. Your homework is just going to be one problem. I think it's 4 questions long, and it's asking about content that's going on in this video. So I highly recommend that you take a look at the problem first, so you know what it is that I'm asking you to answer, and then as I go over the information, you will be able to type up your answers and then submit that to me. So in our last chapter, we're going to be getting into the introduction to statistical tests. Now, before we're getting into confidence intervals, we were just speculating, giving ideas with certain levels of confidence. With tests, we are going to be able to say either yes or no to something. So before we can say yes or no, we have to know what we're saying yes or no to. And then we have to come up with a test statistic to know where our value falls, find the normal distribution of it, so find the probability of that happening. And if that probability is either small enough or large enough, we can then make a conclusion based off of that. So there's going to be a few steps to all these problems, but today is just going to be a, hey, this is how you do it. So first, statistical tests allow us to draw inferences about populations based on samples taken from those said populations. So we do not know what the definitive parameter is for a population, but based off of our samples from that population, we can start to make some inferences about what may be going on or what we think might be going on. Now, the first thing that we have to establish is what we call our null hypothesis. Now, a null hypothesis is what we know or what we assume to be true. So it is information that will be given to us in our problem, and it's our alternate hypothesis is where we're allowed to have a little speculation. So the null hypothesis is known. An example would be the average height of a male professional basketball player is 6.5 feet. One moment. Excuse me. So therefore, I can say that my H sub 0, which in science and in math, that is the null, so it'd be H null. So my null hypothesis is 6.5 feet because that is what's known or thought to be true. They went ahead and they published all the heights of male professional basketball players. They found the average and they said it was 6.5 feet. There's no debating that. That is a fact according to previous studies. Well, someone comes along and they create an alternate hypothesis. An alternate hypothesis is H sub 1. This is what we think may be true. So I might have some sort of evidence that proves this. Maybe I don't, but this is what we are proposing could be happening. And so there are 3 different alternate hypotheses that could be occurring. The first is that we think that H sub 1 is a smaller value than the null hypothesis. So we think the average height of a male professional basketball player is less than 6.5 feet. That's it. That's our conclusion. We think that it's something less than. So we're going to go through, do our statistical test, and based off of our test statistic and the probability of that test statistic occurring, we are going to compare that to what we call a level of significance. And if it is lower or higher, we're going to make our conclusion. We may also think that the null hypothesis is bigger than, or the alternate hypothesis is bigger than the null hypothesis. If that's the case, then we think the average height of a male professional basketball player is more than or taller than 6.5 feet. And then the third conclusion we can make is that the alternate hypothesis is not equal to the null hypothesis, meaning that we think the average height of a male professional basketball player is just something different than 6.5 feet. I can't necessarily say that it's something more or something less than. I just don't think it is 6.5 feet. So therefore, my alternate is that I think it's something other than 6.5 feet. So here are the steps to allow us to make this conclusion. So first, we want to be able to state the null and the alternate hypotheses. So they are going to ask you in the problem, what is the null hypothesis? What is the alternate hypothesis? So you have to look for what is the known parameter, what is what we think to be true, and then what are they thinking might actually be happening. Number 2, we want to find a test statistic. So we will have all this information in the problem, and we want to find our z-score that corresponds with this raw value that we found. And we do that by using this formula here. And then the third step is we want to find the probability of the test statistic occurring. Now that's what we're going to call our p-value. The p-value is the probability of the test statistic occurring. So we do the normal distribution, our test statistic, our mean, our standard deviation, and then true or false. It's going to be true because we are not doing exactly at one point, we are doing a range of values. So I might as well just erase this F because we're going to be doing true every time, but these are just the options in the Google command, and I know some of you are still struggling with that. So make sure you are doing still true. After we find the probability, we are going to compare that p-value to the given level of significance, which is a new Greek letter, that's alpha. So alpha is called our level of significance. That is the value that we are going to compare our p-value to, p-value being the probability of the test statistic occurring. We're going to compare the p-value to alpha, the level of significance. And then once we make that comparison, we will then be able to make a conclusion. Now we have 2 conclusions. The first one is that if the p-value is less than or smaller than alpha. So let's say alpha is 5%. If our p-value were to be 4%, then we can say that we can reject the null hypothesis, meaning what was thought to be true, we're rejecting that because it's not going to be that. And then we can go and we can test to see about what it actually is. But according to our hypothesis, according to what we're thinking, the probability would be small enough that we can go ahead and reject the null hypothesis. Notice how I did not say that I am accepting my alternate hypothesis. I am not making the conclusion that it is definitely something less than, more than, or different. I don't know that. What I know is that I'm definitely rejecting it, and then I might be able to assume something else. If the p-value is more than the given alpha value, then we do not reject the null hypothesis, and we cannot proceed with saying that it's something more than, less than, or different. So those are kind of the two things that we're looking for, and then based off of that, we either reject what is known to be true, or we do not reject what's known to be true. And then, of course, writing a conclusion in context to the problem, not is context to the problem, in context to the problem. We'll go ahead and conclusion in context. There we go. All right, a little background information on the significance of alpha. Now, we've already used alpha. We used it last chapter. If you recall, when we had a confidence level, the percentage that you put in to find the margin of error was alpha. So that was the leftover from the level of confidence. Now, in these problems, they're not talking about a level of confidence. They just tell you that alpha is blah. Now, here's a little more of a background of alpha. Now, in these test statistics, we have two types of error. Type 1 error is when we think that the null hypothesis, so what we assume to be true, we think that it is wrong, but in reality, it isn't. So we think that there's some sort of miscalculation, and I've used this example before, but we're in a manufacturing plant. Your job is to keep a machine tuned, and it needs to drill a hole into sheet metal into the same location within 1/100th of a centimeter over and over and over again. Now, all of a sudden you think, maybe my machine is a little uncalibrated and it's a little out of whack. So you shut down your area, you recalibrate the machine, come to find out there was nothing wrong with it to begin with. But you wasted a little bit of time, maybe you wasted some money, but no harm, no foul. You're able to continue the production and there was never any error with your machine. Now, the fact that you stopped the production and you recalibrated the machine, you made a mistake. You thought that something was wrong and it wasn't. That's a type 1 error. That is more acceptable in the world around us than a type 2 error. It's okay if you are overly cautious. You don't want to be overly cautious all the time, but someone's probably not going to call you into the office and be like, look, you shut your machine down for an hour to recalibrate when nothing was wrong. Why'd you do that? Well, that's an easy conversation, and that's a personality thing. Maybe your boss doesn't want you to be that overly cautious. Maybe they'll say, you know what, that's a good idea. We should do this every Friday, something like that. Type 1 error. A type 2 error is when we don't think that the known average, the known hypothesis is wrong, but it actually is. So you didn't take the time to calibrate your machine. You just kept going, you kept drilling, and it was off from the mark. So all that work that you did all day long or until they finally caught the mistake is trash. You wasted time, you wasted money, you might have wasted the company's reputation because those pieces of sheet metal moved on somewhere else to be part of a different thing. That different thing now cannot be created or assembled because the part that you were responsible for was junk. And now maybe a company bought those pieces of sheet metal from you. They're probably not going to buy from you again because you just wasted all their time and money as well. So that's a type 2 error. That is not acceptable in the working force. If you make a mistake and you cause your company a lot of time and a lot of money and a lot of stress, that's not a conversation of, why did you do it? It's more like, grab a box, pack up your things, we're all set. So a type 1 error is more forgivable. You think something's wrong, you're overly cautious and everything's fine, move forward. Type 2 is when you're ignorant and you don't think that anything's wrong with it, but then something was wrong with it. That is denoted with the Greek letter of beta. So that's that little B symbol right here. Now, we are only going to be using our type 1 error. So we're working in the world that we are making a mistake, but it's not that bad of a mistake. Future chapters get into beta and type 2 errors. We're not going to be working with beta. We're only working with alpha. So a type 1 error would be alpha. That's the probability of thinking something's wrong when it isn't. And then type 2 is beta. That's thinking that something isn't wrong when it actually is. So again, take a look at those questions. Tomorrow we'll be doing more application. I just want to make sure that we have the concept of type 1, type 2 errors, alpha, as well as our point statistic, p-value, null hypothesis, and alternate hypothesis. So hopefully that makes sense. I'll be in Zoom if you have any questions at all.